Good morning, everyone. Thank you very much for attending this presentation. Today, I will be talking about how we can utilize laser as a communication concept in space application. In this, we will have this agenda. I will start with my objective. What is the current space communication systems available, especially NASA, and how we can implement and what is the limitation we have and what action and process. This presentation right now is just an overview of a grant I'm working on, so hopefully we will get it through from NASA. So we will try to understand the concept of laser, why we need to use it, and how we can utilize it to improve the space systems industry. So as you know, probes, spacecraft, satellites, they have been developed for a long time. And NASA, they have been using the RF, radio frequency, communication for a long time. I know this system is reliable, but it's outdated. And they have a lot of problem with it, especially when they have multiple frequency range and the time lag because of that. So let's start talking about the radio frequency. It's well known for us. We use it every day. You have it for your radio, TVs, stations, satellite, and even your cellular phones. NASA, right now, they have the capability to send around 25 megabit of data from a rover on the Mars to the Earth. But that will take 20 hours at least. With that long time, we have a big issue, lag. And I'm sure all of you are aware of the rover and what happened with it. It broke down, and they did not notice that till around a few hours later when they saw the drag path he created. So they weren't able to have a live video streaming or any high definition pictures. So with laser, which is being used in multiple small applications, mainly code scanners, CDs, printer, and pointers. And right now there is an issue about laser pointers. It can go very far with high accuracy. So why we can't use that? Bless you. The laser, it does have a high speed, 10 to 100 times the radio frequency. So with having that capability to send data very fast in a reliable way, we can have zero lag, a zero delay. In our communication. So if you are dealing with internet, right now they are using fibers, which is the highest end of communication. With laser, it will be wireless, and it should be fast as well. So the laser beam, if it can be sent from the Earth station to any satellite in the space, it will take a second. It does have the ability to download around 600 megabit per second with a rate of 19 megabit per second as well. So that is really extremely fast rate for a wireless. And the only issue is how we can control that path of laser. We cannot have a direct sight or direct communication between the sender and receiver. So in my projects and the grant I'm working on, we are trying to build a controller and a simulation model to design and identify the optimum path for that laser, including all the available resources I will be talking about next. So right now, as I mentioned, the Mars rover, they use the radio frequency. It's long delay transmitting live pictures and videos, and of course that will result in a slow response. The ground station won't be able to communicate or control the robot in a timely manner to prevent any damage or any disaster. And if you were looking to the news, at a certain point, NASA had lost faith in that rover, and they said it's lost and we won't be able to get it back. But luckily, it happened. So with that, have in mind, if we can use laser and send it between the Earth and Mars, when these two planets are close to each other, that's 3 seconds. So imagine reducing 20 hours to 3 seconds. Even the farthest distance between these two planets, it will be around 22 minutes, which is a significant reduction. Why I'm talking about this? Recently, NASA, they have an annual competition to build and create robots for a mining competition, so they can use the technology and the ideas. We were one of the competent universities there, and we had a lot of issue, especially with communication. So NASA starts using laser communication demonstration devices. They can send a pulse in between the moon and the Earth without any issue, because there is a straight sight of that. And they have multiple stations, they can control it. And hopefully, by the 2017, they will send the first satellite that use this technology. But till that time, we are in process of developing a way to create the optimum path. So if we need to do that, we have to study the space. What plans there? What is our resources there? We have some satellites, we have some stations that we can use to reflect or pass data from one location to another. And we have to include the turbulence that might happen for the laser in that ambient. Especially, there is a lot of obstacles that either absorb or scatter the laser. So what is being done right now? We are collecting data and trying to see how we can integrate a fuzzy logic and neural network and create a controller to calculate that optimum trajectory for the laser, including the location of all the available satellites, planets, and any obstacles that might happen that time. And we will be having an integrated GPS system in each of these satellites, which is already there. We just need to utilize it to send it to the ground station and identify the closest, the safest path to send the data from one location to another. So we will be using these satellites like routers. They will move the signal from one side to another. So as a demonstration, we will have multiple satellites. Each one of them will communicate with the other using laser. And these satellites' location are predefined or can be calculated over time. We will be calculating the speed, the direction of rotation, and even the ground rotation and time. And using this information, we will be able to create the required path to send the data as simple as we can with less distortion and the fastest time. So hopefully we can do that within the coming few months. We are working on that right now. We are in the phase of collecting data and trying to implement the fuzzy logic. Why we need to implement this? As I said, faster approach so we can create or find a new discovery. It had been 10 years since they sent the satellite to take a picture of Pluto, and it was recent. So if we can expedite the speed of transmitting this information, we will be able to have a better chance to go further out and find new plans. I know it was quick. If you have any question, please let me know. I know I did not include any data because it's still in the process of getting the grant and we cannot publish this yet. So, yes.
Yeah, I'd like to know the range propagation characteristics of this laser as compared to traditional RF signals.
Right now, we are not decided which type of laser we need to use. We have multiple, but all of that will depend on NASA because we need to get a system compatible with whatever they have. We cannot come up with a new system. For sure, they will reject it. So hopefully within, it will be, we have a meeting with them on end of August. So hopefully we will be able to figure out a starting point for us. So we will see whatever they are using in the laser communication demonstration systems they have and try to build on that.
I guess I don't understand that. What I mean is that do you mean to say that the propagation characteristics depends on the type of laser?
Their devices, they have a certain processing rate. So the laser will be using to send the data according to the pulse modulation, it will be different according to what their standards require. We cannot come up with a general one and give it to them. It should be within NASA accepted standards.
Yeah, I understand that. But what I mean is that for RF, typically if you know the power and you know the frequency, you can find the range very easily. I was wondering if you have something like that with laser.
Yeah, we do have the pulse, the power, and we have two more characteristics that we are using to identify this laser. Yes, we do have it. Yes.
You mentioned using fuzzy logic neural networks to
Yeah.
train the control of. You mentioned using fuzzy logic and neural networks to control, I believe, the aiming of your laser.
Yes.
And of course, you need data to train that system. So since it sounds like this hasn't been done before, how do you train those systems?
First of all, we will be using the LCD from NASA as a base seed for our data because they already tested from the Earth to the Moon, and we will be using that data and integrate the new GPS location for these satellites, hopefully, and try to target the destination we need. The data is not published yet from NASA, and that's why it's a little bit restricted. Once we have the grant, they will allow us to see what data we have and what we can do with it. Any other question? Yes.
So if you get the grant, how? Okay, if you get the grant, how long will the project take? Is it a 1-year project, 2 years, 5 years?
No, I think from my communication with them, it will be at least 5 years. Yeah, because they are still in the basic stage where they use their devices, but still they have some issues with that. So we are planning to develop it, and whenever they launch the satellite on 2017, we will be having a real-life implementation, not like simulation only. No more question?